The class mark midpoint. Welcome, everyone. To begin today's lesson, let's take a quick look back at what we've already covered. In our previous section, we discussed how we take large, messy datasets and organize them into neat, manageable groups called class intervals. Now, as we move into calculating the mean, we run into a bit of a mathematical hurdle. You see, when we are working with these intervals, we are dealing with a range of values, such as 10 to 20. The problem is you cannot perform standard arithmetic operations, like addition or division, directly on a range or a hyphenated interval. You can't simply add 10 to 20 to find an average. Because of this, we face a challenge. We need a way to find a single, specific numerical value that can act as a representative for every single observation tucked away inside that specific class interval. We need one number to stand in for the whole group. This essential representative value is what we call the class mark, which you might also hear referred to as the midpoint. Over the next few slides, I will show you exactly how we find this value and why it is so crucial for our upcoming calculations. Understanding the concept. Now that we've established that we need a single value to represent a range of numbers, let's dive deeper into the concept itself. Think of the class mark as the exact, perfect center of your class interval. If you imagine your interval as a line, the class mark sits right in the middle. Now, you might wonder, how can one number represent a whole group of different values? Well, in statistics, we make a very helpful assumption. We assume that the data points within each class are evenly distributed. This means we act as if the values are spread out uniformly across the interval. Because of this assumption, we can treat the frequency, or the number of observations, as if they are all concentrated right at that midpoint. By calculating this class mark, we are essentially performing a clever trick. We are converting a group or a range of data into a single, manageable numerical value. And this is crucial, because once we have this single value for every interval, we can finally move forward and apply our mathematical formulas to calculate the mean, which is exactly what we will see in the next few slides. The formula. Now that we understand why we need a single representative value for each group, let's look at how we actually calculate it. To find the class mark, which we denote as x sub I, we simply calculate the average of the two boundaries of our interval. Specifically, the formula is class mark x sub I equals the upper class limit plus the lower class limit, all divided by 2. Essentially, you are just finding the arithmetic mean of the two limits to locate that exact center point we discussed in the previous slide. Step-by-step calculation process. First, you need to identify the lower class limit. This is simply the smallest value that falls within your specific group or interval. Second, identify the upper class limit. This is the largest value that marks the boundary or the end of that same group. Third, once you have both numbers, calculate their sum. This means you will add the lower class limit and the upper class limit together. Finally, take that resulting sum and divide it by 2. By dividing by 2, you are finding the exact center, or the midpoint, of the interval. Now that we have seen the formula on the previous slide, let's break down exactly how to apply it. To find the class mark, you can follow this simple 4-step process. We are going to put this exact process into practice in the next few slides using a real-world example involving parcel weights. Real-world example. Now that we have covered the theory and the formula, let's put this into practice with a real-world scenario. Imagine a courier company is managing a large shipment of 50 parcels. To make the data easier to handle, they haven't recorded every single exact weight, but have instead grouped them into class intervals. Our task is to apply the formula we just learned to find the class marks for 3 specific weight intervals. First, we have interval A, which ranges from 0 to 10 kilograms. Next, we have interval B, covering 10 to 20 kilograms. And finally, we have interval C, which spans from 20 to 30 kilograms. In the next few slides, we will walk through the step-by-step calculation for each of these intervals to see how we arrive at their respective midpoints. Step-by-step calculation for interval A, $0.10 kg. Now that we have our scenario from the previous slide, where we are looking at the weights of parcels for a courier company, let's apply the formula we just learned to our first interval. Looking at interval A, which ranges from 0 to 10 kilograms, we start by identifying our boundaries. First, our lower class limit is 0. Second, our upper class limit is 10. Following the step-by-step process I outlined in the previous slide, we first find the sum by adding the lower limit and the upper limit, which gives us 0 plus 10, equaling 10. Finally, to find the class mark, which we will denote as x sub 1, we take that sum of 10 and divide it by 2. This gives us a class mark of 5 kilograms. So, for this first group of parcels, we will use the single value of 5 kilograms to represent the entire range. Step-by-step calculation for interval B, $10.20 kg. Now that we have successfully calculated the class mark for our first interval, let's apply that same logic to interval B. Looking at our data, the second weight interval ranges from 10 to 20 kilograms. First, we identify our lower class limit, which is 10, and our upper class limit, which is 20. Following the formula we learned earlier, we start by finding the sum of these two limits. So, 10 plus 20 gives us 30. Finally, to find the exact center, we divide that sum by 2. This gives us a class mark, which we denote as x sub 2, of 15 kilograms. You'll notice this follows the exact same pattern we used for interval A, and we will see this same process repeated one last time for interval C in the next slide. Step-by-step calculation for interval C, $20.30 kg. Now, let's apply that same logic to our final interval, which is interval C, ranging from 20 to 30 kilograms. First, we identify our lower class limit, which is 20. Next, we look at our upper class limit, which is 30. Following the steps we used in the previous two examples, we start by finding the sum, so 20 plus 30 gives us 50. Finally, to find the class mark, which we denote as x sub 3, we divide that sum of 50 by 2. This gives us a class mark of 25 kilograms. So, just like the previous intervals, we have successfully found the exact midpoint for this group. Common mistakes to avoid. First, a very common mistake is confusing the class mark with the class size. Remember, the class size is the difference between the limits, which means you subtract the lower limit from the upper limit. However, as we practiced in the previous examples, the class mark is the average of the limits, which means you add the upper limit and the lower limit together, and then divide that sum by 2. Don't mix up subtraction with addition. Second, watch out for simple calculation errors during the addition step. It sounds basic, but when you are working with larger datasets, or even more complex numbers like decimals or negative values, it is easy to make a mistake. Always double-check that you have correctly summed the limits before you proceed to divide by 2. Finally, be careful with incorrect limit identification. When you are calculating the midpoints for a whole table of data, like the parcel weights we looked at earlier, ensure you are always using the upper and lower limits from the same class interval. Don't accidentally grab a limit from the interval above or below. Now, before we wrap up today's lesson, I want to pause and highlight some common pitfalls. Even if you understand the concept of the midpoint, it is very easy to make small errors that can throw off your entire calculation. If you avoid these 3 mistakes, you'll be well on your way to mastering grouped data calculations. Key takeaways. First, remember that when we are dealing with grouped data, we can't work with a whole range of numbers at once. That is why the class mark is so important. It serves as that single, specific value that represents an entire class interval. As we saw in our step-by-step examples with the parcel weights, you can think of the class mark essentially as the midpoint of the interval. It is the exact center point between your boundaries. To make sure you can perform this calculation accurately every time, keep this formula in mind. X sub I equals the upper class limit plus the lower class limit, all divided by 2. Finally, please keep in mind that mastering the class mark is not just an isolated skill. It is a fundamental building block that you will need for our upcoming lessons, as it is absolutely essential for calculating the mean using the direct method, the assumed mean method, and the step deviation method. All right, we have reached the end of our lesson, so let's wrap everything up by reviewing the key takeaways from today's session. Great job today! Make sure to practice these calculations to ensure you don't confuse the class mark with the class size, as we discussed in our common mistakes slide. I'll see you in the next lesson.